we're going to talk about how to create Bohr models for atoms. And we're also going to be able to answer the 11 essential questions that are going to be asked about a Bohr model on your Chemistry 1 test. The Bohr model is a simplified model of the configuration of the particles, electrons, protons, and neutrons that make up an atom. These are the main subatomic particles. An electron has a negative charge. Its symbol is the letter E with a minus sign. It has a mass of 0.00055 AMUs, so they're incredibly small. Since they're incredibly small, we don't count them in determining their mass. So in the event that you even had 118, which is the largest element on the periodic table, they would not equal the mass of a proton. A proton has a positive charge. Its symbol is a P with a superscripted plus sign. It has a mass of 1.007 AMUs, and we generally just call that 1 AMU. They are found in the center of a Bohr model because they are found in the nucleus. The other thing that is found in the nucleus are the neutrons, and they have no charge. Their official symbol is an N, sometimes with a little 0 there, indicating that it has no charge, but most of the time people just leave that little 0 off. It has the mass of 1.008 AMUs, and we generally just call that 1 as well. To figure out the number of neutrons, you don't get that listed directly on the periodic table like you do the number of protons. Let's take nitrogen, for example. If we were looking at a box on the periodic table for nitrogen, it would have its symbol, most likely its name. It would have a number 7, which is the atomic number, and then a number 14 point, it's 0 to whatever. We're just going to round it to 14 for right now. So this larger number is the number of protons plus neutrons, and that's called the atomic mass. So the mass is equal to the number of protons and neutrons. This 7 is the number of just the protons. So by looking at the periodic table, I can determine the number of neutrons by doing a math problem of the mass, which is in this case 14, minus the atomic number, or the number of protons, which is a 7, and that's going to give me, in this case, 7 neutrons. The other thing we might want to discuss before we get any further is the definition of an atom, and that is the smallest particle of an element that still has the properties of that element. That's an atom. If I start talking about these subatomic particles of protons, neutrons, and electrons, they don't have the properties of the element nitrogen. So they are subatomic particles. To know how many electrons are going to be distributed into your model, and the model of a Bohr model generally has a center where they tell you the number of protons, and then it has electrons that are in orbits like planets around the nucleus. So there are names for those sections. The first one is the K orbital, the one closest to the nucleus. The second one is the L, and then the final one is the M. And those hold a different number of electrons. The way I remember that the one closest to the middle only holds 2 is because it is so close to the nucleus here, there's not that much room for the 8 that this holds. So it holds a smaller number. So the K, which is closest to the nucleus, only can hold 2 electrons. So the one closest to the nucleus holds only 2 electrons. 2 electrons. And that name of that orbital is called the K. The next orbital can hold up to 8 electrons. That orbital is called the L. And then following one on a Bohr model is called the M, and it also holds 8 electrons. Now there are other orbitals, but we're not discussing them right now with a Bohr model. They will be addressed when we get to more complicated models. So the first question here is asking, is this diagram showing you something that's stable or unstable? The definition of whether or not something is stable or unstable is whether its outermost orbitals are filled. This happens to be helium, and it only has one ring. And how many electrons are in that orbital? We count them, and there are 2. How many does the K orbital hold? It can hold 2. So this is stable. It's stable because it has a full outermost orbital. Is this diagram that they're showing you in this picture, is it something that is charged or neutral? They are letting you know that it is neutral. How are you neutral? Because your pluses and your minuses equal each other. Now, which things have a plus? The protons. Which things have a minus? The electrons. Sometimes they don't show you this P and 7. Sometimes they just draw the nucleus with a number 7 in the center. So you'd have something that was in a square or maybe in a circle with the rings surrounding it, and they would only tell you how many plus signs it has. Remember, the plus is telling you the number of protons. Then to figure out the number of electrons to find if it's neutral, you count them. So 1, 2, 3, 4, 5, 6, 7. You'll notice that I counted the electrons and counted them off by crossing them out as I did that. That will make it to where I can not accidentally count something twice or not something at all. This wouldn't have been a problem with this small of a model, but the models can get bigger. The next question is asking, is this noble or ignoble? And ignoble is a fancy way of just saying it's not noble. So, how do you know whether or not something is noble or ignoble? To be noble, you meet 2 criteria. Your outer shell is filled, and at the same time, you are neutral. So, I will tell you a little trick. You've heard of some noble gases, haven't you? Those are the only ones that are noble. They're the only ones that meet these two criteria. Your outermost orbital filled while still being neutral. This one is ignoble because its outermost orbital only has 1, 2, 3, 4, 5 electrons, and it can hold 8. So this is ignoble. The next kind of question that you'd be asked is whether or not this is an atom, an ion, or a molecule. The molecule word is just kind of a decoy, because you really, with only one thing, can only be an atom or an ion. This particular one says it's an atom. Remember, atoms by definition are neutral, which means they have the same number of protons as they do electrons. This is showing you that you have 7 protons. If you have 7 protons, how do you know if you're an atom? You count. 1, 2, 3, 4, 5, 6, 7 electrons. So I have 7 protons and 7 electrons. That makes me neutral, and therefore I am an atom. Just to refresh our memories before we make our first model on ourselves, the K orbital holds 2. It is the first ring, and it's the closest to the nucleus. The L holds 8. It is the second one from the nucleus. The M holds 8. It is the third one from the nucleus. And although we can have more orbitals, we're not talking about them today. Let's create our first model, and we're going to go ahead and make it for the element fluorine. Now, if you are assigned the element fluorine, how do you know already that that's an atom? You do because the ending here is INE. And if it was an ion, it would have ended in IDE. So since this picture is giving you an ending of INE, that would mean automatically we're going to make an atom. The symbol for fluorine is the letter F. The numbers that you can get off the periodic table is you can get the number of protons from the atomic number. That's the number 9. And you can get the mass number off of the periodic table as well. For fluorine, it is 18.9 something, and we're just going to round that to the closest whole number, which is 19. To figure out the number of neutrons, you simply take the mass number minus the number of protons, and that gives you 10 as the number of neutrons. We've already said that this is an atom, so that means the charge is 0, and therefore it is also, by the way, neutral. So those things are interrelated and connected. So you want to make sure that you get those right away before you move on so that you can get those answers correct. So if I know the charge is 0, the net charge is 0, and I know that the plus signs, 9 of them are the protons, that would let me know that I'm going to have to distribute 9 electrons. If I know the total of the electrons is 9, how many of them will be in the k orbital? The k orbital only holds 2. That leaves me 7 electrons to be distributed into the L. You don't have an m orbital in this particular model. However, of course, the template shows it because I can't make it disappear upon doing a different model. So I distribute 1, 2 electrons to the K, and 1, 2, 3, 4, 5, 6, 7 electrons to the L. The next question it's asking, is this stable or unstable? To know whether it's stable or unstable, remember that makes us look at the last orbital that you filled. And in this case, it's the L. And the question is the outermost orbital filled? And the answer is no. There's 1 electron that could go there because remember the L holds 8. But you only have 7. So that makes this element model unstable. Is this noble or ignoble? Remember, the word ignoble simply means not noble. The easiest way to know this is to know that fluorine is not a noble gas. But there is a definition to being noble. You had to be neutral, which this element is, but you also had to have a full outermost orbital, which this element does not. So it is ignoble. Of course, we could have filled out the atomic number right away from the periodic table because this element was fluorine. I hope this helps you make models for the atoms of Bohr models.